Welcome. Today's lesson is on the Bohr's model. Niels Bohr introduced his model as a support to his hypothesis of how electrons move within a hydrogen atom. In this model, it really shows you the atomic structure and how these electrons will follow certain well-defined pathways within the atom. Today, we're really going to work on just actual drawing of it. And to get started with that, I just want you to be familiar with some of the parts. What we're looking at right here is really just three energy levels of the Bohr's model. But today I really want to actually concentrate on how many electrons are in each of the shells. And these aren't shells, these are various energy levels. But what I'm going to be talking about, the rules I'm going to be talking about are real basic. They only apply for those elements 1 through 20. That's basically hydrogen all the way through calcium. And there's a little bitty thing I need you to kind of remember. It's 2, 8, 8, 2. Those are there's 4 different shells in which in these particular elements electrons will travel. And in each one of those it has only a certain number of electrons. So let me show you what I mean. Before we draw this model of carbon, you need to know that there are, as I said before, 4 shells. And in each shell, there's only so many electrons in each shell. In this case, you can see the first shell, which is nearest the nucleus, we have 2 electrons in it only. And if you go to the next shell around that, it'd be 8. Third shell would be another 8. And then the fourth shell, only 2 electrons. So 2, 8, 8, 2. That's the electron configuration. And the 2 electrons is the one that's closest to the nucleus. Now, in order to draw this, you need a periodic table. What I've done is I've kind of excised an example of that. And I've got carbon. I want to show you carbon. And you can see it's the atomic number 6 and atomic mass of 12. But first of all, let's go ahead and draw it. The first thing you're going to draw is a nucleus, and you want to make sure you show protons and neutrons in the center. Now I'm going to throw down some of the shells. In this model, we'll only need the first and the second. I'll show you some other ones later. Now, we're going to start off with protons. Protons are the positively charged particles in the nucleus. So in this case, the atomic number actually is the number of protons that are in this model. So there are 6 protons in this model. And the other thing I want to be able to look at is the atomic mass, AMU, atomic mass unit. That's what AMU stands for. And in this example, the atomic mass is 12. Now the next thing I want to do is I want to calculate the number of neutrons. Neutrons are neutral, hence the name. In this case, because we have atomic mass of 12, we're going to subtract up the proton 6 from that. So we take the protons, subtract it from the atomic mass, and we get the neutrons, and in this case 6. It's not always the same, by the way. There is some variation. So, and then of course, to balance out the positiveness of the protons, we need to have a stable atom. So to do that, we need 6 electrons in this scenario as well. So let's go ahead and start putting on the electrons, and they go on a certain way. On the inner shell, or the first shell, you can only put 2. And I put mine on the outside. Sometimes you'll see some folks will put it near the top, but I just do it because that's the way I've learned it. Now the next shell, remember there's 2 electrons already there, and that next shell can hold 8, but we only need 6. We already have 2 down, so I'm going to put 1 on the top. Now notice I put it at the very top, and now what you're going to do is go clockwise, and at the, let's say, as a 3 position, we're going to put another, and then at the 6 position, we're going to put another electron. And then the last one is at the 9 o'clock position, and there you have it. That is our 6 electrons. And we have, of course, as I said before, the atomic mass was 6. It was 12, and the protons were 6, and the neutrons were 6. So that's how you draw your first model. So let's go on just a little bit harder with another orbit in it, another shell. And I'm going to be using sodium. Now, sodium may be a little bit more harder to find in the periodic table because it's abbreviated Na, not So. In this case, we have 11 as an atomic number. Our atomic mass is 22.99. We're going to round it up. We're not going to be using a decimal, so in this case we're going to round it up. So it's 22.99, but the AMUs, or atomic mass units, are going to be it's going to be 23. So let's first of all go ahead and put down a nucleus, and then our protons and neutrons, and then our shells. We got 3 in this one. So we came up with protons. We have 11, so those are positive charges. Now we're going to take the atomic mass, which is 23, and subtract 23 from 11 from 23. And when you do that, you get a number of 12 neutrons. And then to balance everything out, because the protons were 11, we have to have 11 electrons. So here we go. We're going to put our first 2 in the inner shell. And now we got to keep track of it. And we got 2. There's 3, 4, 5, 6. Now we've used those up at that time. Now what we're going to do is going to start at the top again and kind of double up. And so we have, at this point, we have the next one, and the next one, and the next one, and the next one. Now that means we have 10 total electrons in the shell 1 and shell 2. We need just one more to make 11, and we're going to put that right on top. So that's how you would do a Bohr's model. That's how you draw it. Now, really, they're relatively easy if you stay within atomic number 1 through 20. And I'm going to give you 6 practice ones. Now, you can either through your Google Classroom, you can print this out if you're at a desktop computer only. Or what you can do is just your instructor should have the practice problems already printed out for you if you prefer. So I would suggest when I show you these 6 problems, I would hope that you would just pause it and then do your work and come back and check it on the last slide. All right, I hope you didn't find that too hard. Probably the hardest one of the bunch is calcium. So let's kind of delve into calcium for just a minute. You've noticed, I think, by now, I've added an extra shell around. And the reason I did that is it needs 4 shells. Because when you start putting them all in, basically you actually fill it all up on shell number 3. You get your 8 in there, and you still need to put 2 more. So the 2 in the center, the 2 in the next one, that would be 10 altogether, and then the next one is 8, that's 18. Then you put 2 more on that 4th shell. So you'd have a total of 20. I hope this has helped, and I'll see you in the lab later. Thanks. Bye.